And especially thanks for coming on such a lovely day. I'm sure there's probably all kinds of things that you could be doing, but hopefully you get some value out of this talk. And they're both from Dev9. Dev9 is a consulting company. We're based out in Kirkland. A couple of us work upstairs at Disney. I think I noticed some of you folks are here from Disney, so thanks for coming. And we've been using Java 8 for the last year or so, I think, on our project.
Almost a year.
Almost a year, yeah. And we've been loving it, and I think the code is definitely a lot cleaner. And we've been seeing a lot of benefit from using it. So our hope is to kind of help send out some more information around that in terms of like how we got it going and how to get people on board with moving to a newer version of Java and using some of the more modern facilities and things like that. So I guess with that in mind, I'm just going to hand it off to Peter and Chris. And if you haven't had a chance, there's pizza back there and stuff. So.
Hey, good evening. Thank you for coming. My name is Peter. That's Chris. And so let's start with what Java 8 is. And one thing, Java has been very popular language, but it's been pretty stagnant. Like last new features introduced to Java were new significant features were around 2005, where generics were introduced, and with Java 8 that had changed. And so basically, what this gave Java, it bridged the gap between this popular old language in the corporate world with the new cooler languages like Scala and Clojure. So now maybe we take a little survey about.
Just a quick. Who here is anybody using Java 8 day in, day out at the job? Nice.
No, you guys are. You?
Read about it, dabbled a bit, tutorials, stuff like that. Okay. I think this is more aimed at that level where it's like, all right, got an idea about it, sounds cool. I'm probably going to be doing it eventually, right? If you're living in the Java world, how do I make that transition? So that's kind of what this is about.
Right. So we were fortunate. We started our project here with Java 7, but we were able, after a couple months, convince our stakeholders that it would be beneficial for us to change. And since then, we made an upgrade, and everybody has been pretty happy. And we just wanted to share some experiences from that. So maybe let's move on to what do we try to cover today. So first we take a look at the features of Java 8 at a glance. And we're not going to go very deep in it, but we just wanted to kind of point out the most important or most significant parts of it.
Just some of the highlights, not too in depth. How to get it in your organization, and hopefully how you might go about doing that. And then once you've got all those that foundation laid, all right, now how do we start using it?
Yeah, and then so the piece that Chris is talking about is they introduced Java 8 to the team, and by far this is my favorite part of the presentation because A, Chris is going to do most of it, and B, it's not tied to Java 8. It is really how do you introduce team to any new technology, and that's much more universal than just introducing Java 8. Then we talk about where to start, and there we try to cover pieces where we found were most beneficial. What gives you the best? What we found gave us the best return for time spent to actually upgrade the code.
I mean, you've got working code, you've got Java 8 with a whole bunch of new features. How are you going to start using your new tools to modify your code base? And there's a couple of places we found were really help jump start you with a bunch of the new features together, how to use them, you get used to them, and
Yeah. So then we move into where to go from there, and this is gonna be almost just like a food for thought. As like we can give you a couple examples what we have done. And this is maybe how to use more advanced features, like how does it change the way you program once you start using language that has more functional features. And towards the end, the last piece we want to talk about is lessons learned. We want to show and showcase some pitfalls and things to avoid when migrating team and projects to the version. And then we end with Q&A. Yeah. So yeah, let's move on to features at glance. Okay, so lambdas. One of the biggest selling point of Java 8 were lambdas, meaning that it's a functionality sent as data, and they're used throughout entire Java infrastructure, to entire Java 8. All the new features of Java, a lot of them they are based on lambda, such as streams and stream processing. And I wanted to kind of maybe show some examples of what actual lambda is and how to pass that, how to use it in the code. So I made a little program, because most of our code we have here is under NDA, so I kind of had to come up with the examples. So they're very trivial. But basically, I wanted to show how to pass lambda into the function. So let's look at this class called person, and there is a function getName. There's a function called getName, and it takes the function and returns the string. So function it's a specific type of lambda, which takes an argument and returns the argument. And there are other specific types of lambdas, such as supplier or consumer, and they're all defined in a Java Java util function interface. But basically, this is what makes possible how Java makes possible to pass in the on-flight code into the method or store it as a variable. And all of this I want to brush on functional interface. All of this is loosely based on functional interface, which is just an informational interface. It's a notation that defines interface with a single method. And so the one thing I want to make clear, because I kind of struggled with it for a while, like, what is this functional interface? Why do I have to use it? It's more informational. I mean, it's truly informational, because you can pass any method into as lambda. It doesn't have to implement functional interface. However, that is the structure that Java came up with to focus on it. So here, now that we looked at that, okay, so we have a method called getName interface implementation. So this is something that we all used to, right? This is how we've all done it before Java 8, when we have a method called person getName, and inside there we create an interface on the fly where we do our logic, right? There's nothing groundbreaking from it. So this is one way to pass the lambda into the method. Now, the next step, as we see getName static method reference. And here, if you see, above there's a class called default decorator, which has a method called default decorate, and inside the method we're passing reference to this static method reference to this function. Is it clear, or is it a little bit going over? Okay. So next we see this is the kind of true lambda, as one can say. We have the method getName, and in here we're defining all the logic, all the functionalities defined on the fly. And as the last piece is it's the instance method reference, where you create the, as you see, generic decorator, and you pass the instance of this method as a reference to the function. I know that may sound trivial, but once you start getting the code and start using it, at least I found it somewhat, there's a bit of a learning curve, like where can you do what and how to start using it, what's the cleaner way of doing that, how is this more beneficial, which way is a little better.
Let me jump in just for a second on the functional interface. Functional interface, as I think of it, is it's an interface with one method. And that makes it really simple for the compiler. So that when you have a method, what are you passing it all into? The get name. You're passing, it's defined as an interface. It's a functional interface. There's only one method on a functional interface. So whatever you pass into it, the compiler knows this is a function. It's a functional interface. There's only one method. You're passing me one method. There's only one thing I can really do. So that's what I'm going to do. It
Right.
keeps it simple so that you can pass in most anything. In this case, a lambda, or a reference to a static method, or a reference to an instance method, if you've got an instance.
Right.
And in any of those cases, what you're passing in is a method, and you feed it a method, it needs one, it just plugs them in. And
Yeah, and to iterate on this, you do not need to implement it. It's not, you do not have to implement it. That's a part of I was struggling with a little bit. I was like, okay, where is this functional interface coming from, right? Because some things have it, some things don't, and you do not need to, technically you do not need to use it, really.
because the compiler can spot it.
Yeah, it can know, it knows where to.
Here's an interface that only has one method declared on that interface, therefore
Right.
it's a functional interface, implicitly.
So, based on a lot of next, like other features that we talked about, they'll be based on Lambda or use them in some degree. So maybe let's move on to the next topic, which is streams.
Sure. Streams are another feature that are kind of built on top of all these lambdas and other little components. The basic idea of a stream, you've got three things. You've got a source of data, you've got some steps they're going through, and then what are you going to do with it at the end? The source typically are collections, doesn't have to be. It could be an unbounded source of random integers or whatever. But you start with the source of things. They each of the things go through a series of steps, and then at the end you want to do something with that. So these are intermediate things, and all of these steps are just setting up the pipeline, and it's not until you get to the end when you go, okay, now let's do a bunch.
One thing to maybe add to streams is that there are two types of operations. One is terminal, I can't remember how the first
Intermediate and terminal.
Intermediate and terminal. And a lot of kind of more advanced features with streams can be done with kind of deferring calling, because intermediate operations are not done until terminal are not being executed.
Right.
Until terminal is being until it's encountered.
Right.
Right.
So, I mean, the streams really want to encourage lazy evaluation. So you're saying, here's a bunch of things, here's a sequence of steps I want you to do on them, go. And the go is, okay, now start evaluating, and I'm going to do something. These terminal operations are one of a couple different categories. There's a yes, no, was there something, did anything make it through, did everything match? There's, hey, find something from that stream, so pick one out. And pick one out, typically you're going to want the first, or that's a common case. So that's a great case for lazy evaluation, right? Because once you find it, you're done. You don't need to evaluate the rest, even when you're transforming things. And then the last one is collect a bunch of them. There's kind of two variants of that. One is just collect them in a list or a map, or so taking one collection and kind of transforming it into another is a common case. And then another one is, you know, take all these bits coming in, or these objects coming in, and condense them or reduce them. I mean, we've all heard the term map reduce at this point. So by some logic, compile them all down into some final result. It's surprising to me the degree to which these were applicable. When we started going through our code, it was like, oh, we can use it there, we can use it there, we can use it there.
Let's say.
Oh, yeah, we'll save that for later. So some of the key characteristics were lazy evaluation, functional type of priorities, like whatever your source is not going to be modified by each of these. It encourages things to you know, return a new object as it goes through, and
Maybe peak. The one thing that we found that was kind of cool is that, you know, once you start building your logic more fluently, there's not any place, like, you know, there's maybe a lot of things happening within this stream, and there's no place to log, right? Like if you want to log, or you wanna introspect what's happening there, right? So that the stream implements a method called peak, where you can actually do add your logging, like because you want to see, okay, I filtered it out. How many do I have, right? So like as for debugging purposes and troubleshooting. So they're pretty well designed.
And yeah, and so you're going to do something, you know, with the result in some sort of terminal operation. If you don't do that, nothing happens.
Nothing happens. Yeah, that was kind of that's another thing. You may go, you know, you're right.
You're building it out, right? You're like, all right, step A, step B, and you know you have more, so you just step A, step B. Let me try it out. Nothing happened.
Right. There's nothing good evaluated. So there's a little bit of learning, but it's definitely worth. It was definitely worth. It definitely makes your life easier as a developer.
Yeah.
Can we move on?
Yeah.
Okay. Oh, another thing that I really like, another feature that I really like are the default methods. Part of the Java 8 features is that you can add default implementation methods on the interface, which I found it very powerful, because a lot, you know, I found it to make it's very hard to get the interface right, especially if you don't know what all the clients want to do and how is it going to evolve. But once you create it, once you made it and it's popular, it is hard to change if there's a lot of clients implementing it. So adding default methods really helps augment kind of your mistakes from the past. You know, you definitely don't want to use them too often, because you know you don't want to overuse this feature. So let's move on to next. Oh, a couple other features I would like to mention is optional, which is a wrapper to reduce the number of null pointer exceptions. Which I found it really useful. It also probably shouldn't be overused. Additional thing that I really liked about it, it has the ability to reduce if statements in your code because of some of the methods that it implements. Some, for example, get or else gets default, so makes your code look prettier. And one more thing I wanted to add is datetime API has been totally redesigned based on Java time, and I think they've done a really good job. And maybe I was just skewed because before that datetime was very bad, so maybe that's why I was just so happy about it.
No, I think they've actually done a better. I think the contributor to Jota time was, or they based a lot of that on
Yeah,
some
yeah,
of the
yeah.
issues in Jota time that people weren't even aware of. So they've actually improved on that in Java 8.
Yeah. Yeah. Thank you.
And the optional is good too, because nobody likes having null checks scattered all throughout their code. So it's much cleaner, like fewer lines of code.
Yeah, thank you. Okay, So one more thing I wanted to note is the garbage collection changes and JDK changes in general. One, there is no paremgen space in Java 8, which is, I think it's just one less parameter, and which sometimes was terminal, right? And another improvement, but which it's not necessarily specific to Java 8, was the introduction to G1 garbage collector improvements. However, from what I read, the Java 8, in Java 8 there are additional improvements. And G1 collector is designed for large heaps and for basically for big server apps that have a lot, they use a lot of memory, have lots of processors, because it tends to use more resources. And supposedly, I had a friend who has a couple big systems just down the street, and he actually tried it, and he said on one system it worked great, but on the other system it would crash. After 2 days the system would just go up of memory and it would crash. So like everything, you have to kind of test. You have to put it through the performance test and configuration. So that's what we have wrapped for changes. Now I'd like to move on to migration steps on how do we move existing project to Java 8. And I somewhat, that may be very specific to your project. That's not, there are some things that everybody has to do. Like, you have to install Java 8, but there are steps that, some upgrades will be easier, some upgrades will be more difficult, and that will depend a lot on the size of your product, or maturity of your product, on automation level in your organization. And most important, it will really depend on your testing coverage. Like, how confident are you in your set of tests? Whether you're willing to, whether you're ready to make a leap of faith and believe that, that you can verify all the changes. And I kind of cheated with this slide a little bit, because like I said, we didn't do all the steps, but there's this really great blog post on HubSpot, which details really good steps on really good progression on how to make it happen in your organization. So let's look what they recommend and what we have done in parts. So as first step, you want to have Java 8 available everywhere. You want to have it installed in every single box, right? Developer box, in pipelines, in Jenkins, TeamCities, anywhere, right? As a second step, you want to build with Java 8, and you still, the point is here, you're still building Java 7 binaries. However, you're using Java 8, JDK 8 to build your code. The next step is you want to run with Java 8, right? Now you're building Java 7 binaries with JDK 8, and you run it on JDK 8, but you're still running Java 7 binaries. Next step, and this is all. Now this is all from the blog. We haven't done it, and at this point we didn't have to do that. We're in a pretty fortunate situation. Our product was only 4 months old. We weren't in production yet. 4 or 5 months old. We're in production with a really good set of tests, from test to integration to functional tests. I think we had like 90% of coverage. Therefore, we were a little more kind of cavalier with our approach, as we didn't have to look at finding. We didn't have to go through a step of finding incompatible dependencies. And if you go to this blog, which the slides will be available, they go in a great detail on how to find them, how to write. They even like provide some scripts how to find dependencies that depend on your incompatible dependencies. So the next step, you want to upgrade incompatible dependencies, and which sometimes is easier said than done, right? If you really deeply rooted project with with all bunch of stuff that you depend on that's not very new, they may be very tough sell. And the last thing is to compile code to Java 8, right? Once this is done, you're ready. You're doing it. You run it everywhere.
So I'm going to point out just one step that you kind of skipped over a little bit. I can't point all the way to the top, but Java 8 available everywhere kind of implies some buy-off already.
Right.
With whoever controls your pipeline, or DevOps, or Ops, or production. So, I mean, there's a little bit of a sales job, but I mean, if your job is to keep some Java software going and developing and delivering new value, I mean,
right.
It's kind of stagnate or progress. So
Yeah, no, that's a great point. And I think at every JDK level, there's a point where you kind of have to upgrade. And I don't think Java 8 is there yet. I think you still, right now it would be very hard to have anything running on like Java 4, right?
Yeah.
Because you can't even do JDK, so you would have to take this step. But yeah,
it's
that's
already hard to get JDK 6.
right.
So
No,
there's a carrot and stick approach, right? You got some great new features for your developers, and the stick is
right.
end of life for older stuff.
Yeah, that's a good point. Okay, so let's move on to my favorite part. Sounds great. Now what?
Yeah, so once you've got all the pieces in place and you're ready to start using Java 8, now you come back to your team and you're like, all right, it's all ready to go. It's up to us. And so most of what I'm going to talk about for a little bit is not really Java 8 related. It's just about the team and how you absorb big new changes. And as you saw, there's some changes in how you can construct your functionality, how they interact and combine with lambdas and such. So those are kind of hopefully encourage you to think a little differently about your code, and so that's learning for everybody in your team. How are you going to do that? It's an opportunity, to progress, to learn. It's a great big reset, right? To say, this is new. Let's reset and approach it together. So yeah, you're resetting expectations. This with the team, with team agreements. Agile is, I don't know if it's end of life yet, but it's certainly at kind of max marketing buzzwords. But there's a kernel of truth in there, and it has to do with team expectations, feedback to each other, pull requests, code reviews, pair programming. You're giving feedback within the team, so before with things you're used to and you're mature with, that's, hey, do this right, and now we're going to use that for, hey, that doesn't look right, or how do I do that better? Or use it for learning and bringing each other up to speed and recalibrating. How does this code look? Is this readable? Is this comprehensible? Can I get this at a quick glance, or is this, I don't get it, and how do you do that? And if you're going to bootstrap, a team with knowledge of some big new thing like Java 8, you're going to have to do it together and kind of just cross-pollinate ideas and everything together. And where you start small, common sense, and until you're comfortable with that level, and then you grow from there. And you usually grow pretty quickly. I got a 1-year-old at home, and so he's growing and learning. And my job is to keep them from crashing into things, off of things. So it's the same thing here, right? You want to limit scope until you're comfortable you're not going to break things or yourself. Yeah, you're resetting expectations, code. With the new Java features, I think how things look tends to be different. With streams, it's much more kind of vertical. I guess I should have pointed that out when we had that example up. Yeah, so there's new techniques and patterns you're going to use in your code. There's new code styles. I know I'm not much of a strong opinion guy on code style. I can go with the flow, but with new features, I like things that make sense, and that kind of changes things.
Right. The one thing we found with streams is that there's a lot of somewhat less methods you need because you can do much more things inline. Because if there was before they were complex, you had to modify a list or map or array you probably had a method for it. And now with this, it is this stream processing just will do that for you. So on the other hand, you have to be careful not to make everything a single method just because we can do stream processing. So that's one kind of learning curve that everybody has to adjust.
Yeah, and with new syntax, with lambdas and things, you're going to see less repetition. Something that used to be a function, like you said, can now be a lambda. And you can kind of extract, oh, I see this logic, go do a thing, handle success, handle error. I see that sort of framework with slight variations in a bunch of places. Well, let's extract that and combine it with a couple of lambdas. And now you can get much more concise, less repetitious code. And so spotting those patterns and looking for opportunities to use them is where a team is interacting and can really help each other. Team, you're learning together. Diversity is good. Experimentation, it's new. It's new in varying degrees to probably everybody on the team. And feedback loops within the team. Talk to each other. Diversity. I know from working with Piotr, he and I think differently about code. Wayne and I think differently about code. So I think what you see, what you think, what you observe is everybody's a little different. So hopefully triangulating between all those, you're going to come up with something that works for most people. People are different. That's the point there. Experimentation, even more than usual, because hopefully, whenever you're developing, if it's old hat, maybe you just crank it out. But for new stuff, hopefully you allow yourself a little time for experimentation and new ways of doing things. Well, this is a whole new language level with new features, so you're going to want to experiment even more. Again, starting small with scope. You're generally going to try and time box it. You don't want to lose too much velocity. That kind of looks bad to whoever's keeping an eye on the team. You don't want to bite off more than you can chew, which is something I tend to do, because I don't know it's too much until I got to the end. Yeah. But that's what your colleagues are for, to be like, hey, bring it back. Feedback to each other. Pair programming is kind of the one-on-one. That was really big for a while. I don't know that it happens that much anymore. It seems to have kind of faded.
Yeah, we more talk about it than we actually do it.
I still like it, but yeah, it's not the most common as much. But pull requests, code reviews, Stash, Git, GitHub, not Git, GitHub, whether in-house or hosted, what have you. Those seem to be much more common these days. And those are still targeted. You put, the team can usually, everybody can see it, but you usually put a few people that you're like, hey, take a look at this for me, will you? So, that's a small subset. And then you have your group communication that's more like, hey, I'm stuck here, or I'm in a quandary, A or B, which one do you think? And with feedback, you're helping each other out. So, I've always found this to be a good thing to invest your time in, and a good code review will take your time. But I appreciate it. I hope you express your appreciation for those who do it for you. Some of the types of feedback you might get, either in any of those scenarios, could be better. What about... Now this is what I call kind of the Socratic feedback. This should be used sparingly. I say this from experience. Because if people think you're playing coy, they'll just get annoyed. But sometimes it's honest, hey, you're observing, hey, I'm seeing, we're repeating information here, or how can we extract this out? Sometimes that's an honest, how do we do X? I feel like there's something there. How can we do it? But if you're just...
Well, another thing, sometimes it's just a perception. Like I got a feedback just recently that I thought there was this really cool kind of routine, and my reviewer said that, you know what, this code is so dense. If your idea is to put most code in the least space, you won't. So and you kind of have to take it, understand that, yeah, this is very clear to me right now because I just went through it, but you kind of have to step back and say, yeah, has it been, so it's not really personal, but you kind of have to understand the different points of view. Like
different points of view, and also acclimatizing to
new features.
New features, and because they do increase, density of
yeah.
logic and what's there. Speaking of acclimatizing, gone too far, either with code density, or sometimes I think I've seen this with the lambdas, in a stream. If you can basically with lambdas you can pass, or with the streams you pass in a lambda, or you can pass in a method reference or a method instance method on an object, and if you're removing more and more information because it's implied, and people need to be comfortable with that. You need to, you and other people, whoever's looking at it, need to be able to actually infer what's implied.
And this is, actually, I would say that this is not only applicable to Java 8. I think the same feedback could be done with JavaScript, with Scala, and with Clojure, like I said, because that's what, when you look at the more advanced languages that let you do more things, it's the people who really know it and are really into that, they write code that is, for somebody coming into that, it's very hard to initially grasp. And maybe that's what was that. Maybe that was a big kind of win for Java, that pretty much almost anybody could maintain the application. And now with Java 8, that may not be true anymore. After once these advanced features find their way into more mainstream.
And I think what that also expresses is, varying comfort levels with, with the new language, and, keep talking about it, and people either get more comfortable or you back off a little bit for now, but maybe push on it later. Formatting presentation, this,
right.
Readability. I'm big on readability and good naming, but, I also recognize that what I think is readable may be different for other folks. It's very dependent on your experience, your history, other languages you've done. So again, that's going to be just conversation with the team, and also in whatever organization you're in, how tightly they like to control that sort of stuff. I'm not that big on tight control of it, but some places are. So new techniques lead to new formatting conventions, and that's a conversation with the team. You're doing it wrong. Again, sparingly. You're all using new tools. You're going to make mistakes. Point them out in a positive, or at least a humorous or positive fashion. And if you know folks, that'll do you well. But you got to point out things that hey, this works, but I don't think you're doing what you think you're doing. Maybe phrased a little better, but that's one that occasionally comes up. And this is feedback, kind of reverse feedback, which is, hey, I checked out your code, it works, I ran the tests, it all works, but I still don't quite get it. How's this working? Where are the pieces fit together? And that sort of stuff. And so that's an opportunity, again, for getting members of the team used to using new stuff. And if it's new to the whole team, it's an opportunity, right, for you to say, hey, this is new, I don't get it, and I feel like this is an opportunity more than most of the time. Most of the time people are not comfortable saying that. I don't know. I don't know what that is. I don't know that. I don't understand that. Can you show it to me? And with Team Reset, that kind of makes that a little more palatable. So I would encourage that. I try to encourage that regardless, but I think this more than most times, I think this is a good time for it. All right, so start small. Like I said, when you don't know what you're doing, start small until you understand things and gradually get more ambitious. It helps if you have good test coverage. Peter mentioned that. You do have good test coverage, right? Because especially if you have good test coverage on small things that you're about to refactor, that's just a great enabler. Small scope plus unit tests equals fast tests, and fast tests and good coverage, fearless refactoring. So that's where you can, with high confidence, be like, was this, now it's this, it's better, it looks good, ready to go.
Just for record, even though it looks good, it will not compile with Java 8 yet, maybe with Java 9.
And again, the small impact while you're getting a feel for what to do and what not to do. All right, let's talk about tests. That's my background, QA for many years. So Java 8, again, because of the support they give you with the refactoring, it's a good opportunity to revisit your tests. I kind of have my mental human metrics. They're qualitative. I want my tests to give me confidence. The test pass, I know it's ready to go. If the test pass and I still am not sure it's ready to go, then my tests aren't doing their duty. So yeah, you really kind of need them. They're your safety net. Delete corrupt, redundant, useless tests. If there's stuff in there and you don't know why they're there, you should probably either learn why they're there or yank them. And hey, maybe they bite you in a little bit, but then you'll know why. Hopefully not too much pain, but and what I'm resisting saying here is fear is the mind killer, right? Usually people don't delete stuff because they don't know, and that's not a really good place to operate from. And they're your safety net, so they're a good thing to have. I don't think there's too much to argue about here. So your basic refactor cycle. Start with good unit tests. Implement it in Java 8. This actually sounds a little similar to your moving to Java 8 sort of stuff. Make it work, make it better, make it pretty. Implement it in Java 8. Some of this is going to be implement and then experiment is, hey, can I use a stream? Yes. No. Can I use method reference here? Would that make it
Right. How can I use the string? Like, that's, there's many ways, there's few ways of using a stream, and I would argue correct, incorrect ways. And maybe I talked about parallel streams.
Okay, yeah. This is your refactor cycle. You probably go through it all the time, but a little more emphasis on the experimentation and maybe a little bit with making it pretty. All right, where to start? So, you talk to the team, you're comfortable, you're going to start doing this thing. One of the place we found that gave us a big bang for the buck on exposure to the new facilities and features of Java 8, where go through your code base and convert loops to streams.
Yeah.
You can't do it all the time, but you can do it a surprising amount of the time. And usually, you know, a loop that's not spread out too much, so it's usually a pretty contained scope. And it really gives you exposure to a lot of these other things that streams make use of. The lambdas which are passed into functional interfaces in various parts of the streams. We didn't really talk about it too much, but at the end of a stream, if you go, hey, take this collection, step A, step B, step C, now find the first thing, you may not have anything, and that's an option.
Yeah, streams return optional in a terminal operation.
They can. And so it's going to give you some exposure to these, familiarity in using these, and hopefully at the end of that you can start to see maybe some hints of how to design with those.
Right, but just converting loops to stream, at least what we found, our code do so much better. And maybe just because it's a new construct, it's more fluid, but you just kind of look at the files like, oh yeah, this is so much nicer than it was before. So that, I think that's the biggest. If there was only one thing implemented in Java 8 and streams, I guess they couldn't do that. Fine, now that's an optional. This was the biggest. I found this to be the biggest benefit.
In part, I think reflecting that is some of what made it work like that is you have this loop. You don't want your loops to get too big, so what do? You extract. Oh, here's the thing. Let me extract that into a method. Extract that into a method. Well, with lambdas, you can concisely and hopefully still in a readable manner bring those back into the loop. You're like, do this, do this, do this. Boom.
Right.
So suddenly you're not spread out quite as much. So, yeah, so we, like I said, we found this was a good way to get used to a lot of these features. And like any new thing, you just want to, you start playing with it and it's awesome. You're going to do everything with it. It's going to make your breakfast and clean the dishes. And so then you start doing it everywhere, and then eventually you start to see the limits. Some places where it doesn't quite fit. Some of the things we bumped into, and you talk about this later?
Yeah.
If you use exceptions as flow control, hey, I'm on a loop, and there's 3 places I can escape from that loop, or throw an exception to get out somewhere else. Sorry, those are using those 2 things. Loops with multiple exits.
Yeah.
Streams aren't that good at that. No, streams are not that. And then exception. Streams don't like exceptions. So if you, if that's something you do within a loop to get elsewhere.
I'm talking about some stuff. Okay, so other things that I've already mentioned, that augmenting existing interfaces with additional methods and optional. And like I said, don't go overboard. I think this is a little bit redundant slide, sorry about that. So let's move to where do we go from here? And this is something that I somewhat struggled with, how to prepare for a presentation, because that will depend a lot on many factors. On a team advancement in Java 8, in time, and how basically what we're trying to say is how do you once you have a basic concepts, or do you started working with that, now you want to start designing with the new features. So one concrete example that I found in our code is that in our service we're making a lot of parallel asynchronous calls, and we had this construct called callable. We're using callables, which are just like Java construct, and we always found them kind of difficult because they were not reusable. They all did something very similar. They basically got some data and then transform the data a little bit and return the result, right? And a lot of times just return the errors. So there was just a lot of them. There were like probably 30 of them in the entire code. And we were able to reduce many of them to just, we passing just 2 lambdas, or lambda taking another lambda to the thread pool, and all of the executor, and all of the logic is much more concise. We don't have to have the references to services and other objects duplicated. Basically, it makes maintenance much cleaner. Again, you do lose a little bit of readability because a lot of stuff is coded. I wish I had a better example, that it's kind of hard to conceptually say it. However, I didn't want to do anything. I didn't want to do anything trivial that maybe had shown exactly what I was trying to say. Now, for you guys who ever use Java 8, do you have any examples you would say, how could you use it? What advanced features you could use? How did it help you? Or
I found that there's pretty good IDE support for it. So just switching over the same types of hints regarding cleaning up your code that came with previous versions come right off the bat. So it makes for a very a pleasant transition, because looking at it from up front, like I have a hard time wrapping my brain around it too, because it's a shift from object-oriented to functional programming. And I've already had a history of focusing towards, I've heard many times on the street that immutability is a good thing. You want immutable objects to pass through your system. You want to reduce the side effects. Everybody wants to reduce their lines of code. So pulling it down and experimenting with it, it seems like, at least for IntelliJ, what I was using, I received a lot of help right off the bat from my IDE. It didn't have to, so having some code in place made it a lot easier to start converting over and learning than just trying to pull something down from scratch and write it from scratch. So that was a good experience.
yeah, no, definitely. I did support that. I didn't see any issues with that. So the one other thing I was going to mention, I don't have it there. Libraries that have been developed based on Java 8 streams technology. I think one of them is JOQL. It's a SQL library, and they explore how to use lambdas and streams to pull data from the data stores. And this I would call maybe more advanced usage, but I haven't really explored with it. That's why I was hoping maybe we get some feedback from audience. But hey, so let's move on to the next topic, which is things to consider. So one thing I was going to mention, if this is where, if part of your if you're upgrading only part of your system, meaning you don't doing wholesale change you're not doing wholesale change in entire organization to Java 8. One thing to consider is not to prematurely upgrade libraries that are shared by other projects, which cannot be upgraded. So that's you just can't do that, because they will, once you do that, they will have to be forked, or they just can't update them, right? Another thing that I wanted to mention is something that Chris had already mentioned about streams and checked exceptions, on which I had changed my 180 degrees how I consider that. Because initially when we started porting it, some of our streams they would throw they wouldn't compile, right? If there's a lambda method called from within the stream that calls the checked exceptions, that's not gonna work. And so we started reading about it and looking at that it was a conscious decision by the designers to drop it from the implementation and The reason for it was that you would increase the size of the library, size of the calls by 2/3 or 1/3 or by some giant number, just because they would have to, all the methods would have to be, would have to have a typed exception thrown. And then we started thinking and looking what do we get if the exception is thrown from within a stream. So imagine you have a collection of a couple items, right? And you processing them, and one of them throws an exception from there. Where does it leave you with the reporting, right? What you gonna do? How do you know which one? Let's say you're processing 4 records, and 1/3 of them throws an error. How would you throw an exception, checked exception? How would you know which one of them to? How many of them has been processed? What's the current state of your system? Therefore, we kind of it really wasn't a big issue for us, but however there are some. Another thing to consider is, so what we end up doing, we wrapped calls throwing checked exceptions and we basically return a result that indicated whether there was an error or success, and that was the right solution from the probably was the right solution from the beginning. However, there is a really cool library out there. It's very mature because I don't think the guy who did this he doesn't even have it released. It's just a Git project, but it has a really advanced and cool ways of how to explore features of Java 8 and how to wrap checked exceptions, rethrow them at will, and it's just for almost entertainment or as a kind of a learning curve for what's possible. It is I would encourage everybody to take a look at it. So it's called expressions. So the next thing I was gonna talk about is parallel streams. And as Java 8 came out, parallel streams they were really big feature, very heralded feature, a very prominent feature. And there's several issues with them. One is general multi-threading consideration. So that's what Chris mentioned before. There is different ways of using streams. So initially, when we started working with streams, as we were going with it, let's say we had the code calling. Okay, we created an object, right? We created a stream, and we ran through the stream, and we kept updating this object from within the stream, right? Then, now imagine that this stream is parallel, right? Where does it get you? Well, that means that this object, whichever is updated from within the stream, has to be thread safe, right? And it's not very obvious just from the signature. However, I don't think this is such a big deal, right? Because the stream is parallel. I know I have to synchronize. Well, the bigger issue with parallel streams are, I've done quite a bit of multi-threading programming, and once you get in it, you kind of learn that you need to be careful where the thread's coming from, right? You put a lot of thought at how many, I need a thread pool, how many threads to configure, how is it gonna grow? So with the parallel stream, threads are coming from fork, join, pull, comma, which is just one in JDK. So the issues you may run into is that once you're using this feature and somebody else is using it, or even you using it in a multi-threading environment, you will run into pauses in your pauses in your processing because your threads get exhausted, right? Like if somebody is using it and you using it and there's not enough, you're gonna have to wait. You starve the pool. And you know, if you're working on a desktop app that you know where your thread's coming from, you control your environment, that's not a big deal, right? I know where my thread's coming from. I can use them. Nobody else is using them. However, most of us probably work in web applications, and at the point you're not sure what is running at any point you're processing your request, you don't know what's running, right? You don't know if some other process doesn't update, doesn't use the same feature, and you end up starving your pool and having unforeseen pauses at your process.
So what you're saying is you don't really have much control over the partition of creating these pools of threads and where it's drawn from.
Right. Well, there is a solution. There is actually, I was gonna go in with that. There is a solution for parallel stream problem. So you can supply your own fork join pool. However, you kind of have to look for it. You don't find it in a I was gonna say in an Oracle tutorial on parallel stream. You kind of have to find it. You have to find it either hardware or you have to kind of look for it. And idea is, if you see it here, that you create your own fork join pool, and then you submit your entire stream as a lambda to this pool, and that causes it to use the threads from the pool that you've just created, leaving the JDK pool unattached, not used. However, the one issue you run into with this is that you have to handle exception. You cannot lose the beauty of it, right? The beauty of the parallel stream is that, hey, I have this stream, and now I can just, with one keyword, I can make it parallel. Well, you can't, because now you have to catch exception, create your fork join pool. So it's not as pretty. And on a side note about this slide, I was going to say, I picked this solution out from the blog. And for all the bloggers out there, can you please make sure your code compiles before you put it out there? Because I spent some time trying to fix it. So.
And did you let them know when you wanted
I
to do
didn't.
it?
No, I didn't. He would say, good, compile. I mean,
Remember what I was saying about feedback?
Right. Yeah, I guess I will maybe tonight. So I think this is mostly what we had for today. So these are the references that
I had one more that I came up with just right before this talk, just on things to consider. I mean, one of the things with Java 8 is you're kind of hopefully separating some of your higher level patterns that you can plug some lambdas into. That's one of the things you can do with it. But I think one of the challenges when I took a step back from that is, all right, you're pulling back these abstract patterns that you're plugging lambdas into. How do you test that? As your code gets more abstract, the pieces of it, how are you going to test that? And are those tests meaningful, when they're so abstract? So I think that's kind of an interesting QA challenge. Interesting challenge on the QA side of things is establishing confidence when you've got these components that you can plug together in many ways. Are you just testing, we're going to do this combination and that combination, so I'm testing the combinations, or are you testing the pieces plus the mechanism for combining them? And that's actually really great plug for our next talk also. Stay tuned.
Yeah. So I don't know, any questions do you have?
Actually, I think you guys had lessons learned session. Is that?
Oh yeah.
Did we mislabel it?
We may have mislabeled it. So sorry. We talked about Well, I guess we didn't do the itinerary, right? Okay, so one was things to consider, and
Lessons learned equals things to consider.
Oh,
and also, you know, what we talked about, you know, streams and you know, what gives you the most, like we said, what I thought gave us the biggest benefit with the streams, and that's what I would encourage everybody to start with, because the converting loops, list and array manipulation.
I found this one kind of interesting. You know, there were a couple places where they were like, all right, I got this processing loop, go through and do this, you know, handle a bunch of things. And there were like 3 or 4 exit conditions at different points in the loop. And I kept trying to get a stream. It's like, it's a stream, I could see the steps. And I wanted basically like a possibly terminal operation. Or I wanted to throw an exception to jump out of there, and didn't like that. So there was a couple places with that. And then the other one for me was optional. Optionals, it helps, you know, reduces, like you said, some if statements, and hopefully reduces your null pointer exceptions. And it basically, you know, with default, using it for default values, you'd be like, hey, if I got something cool, otherwise default.
Right.
Except I wanted to go not just A or B, but A or B or C. So like chaining optional, that was
Yeah.
one where,
Yeah.
again, I don't know how common that would be, but that was one where it was like, I'm close, I can feel it, but didn't quite fit.
So, if by chance optional is like a language supported implementation of the new object pattern?
Let's see, I wouldn't say I'm familiar enough with the null object pattern, but I believe that is true.
Yes, I think that's exactly what it is. Yeah, and it's a router, yeah.
Yeah, basically the null object pattern, when you return something, you document that instead of returning null, if certain condition is applied, you return just like you were saying, you know, a wrapper that just contains nothing. So at least you can invoke functions, and those functions will not do anything or will return always the default values, etc. Because you don't have a true object, you know, but at least it's not null. So you don't have to do the checking, you know, so
Yeah.
that's basically.
The interesting side effect of that is that your code won't blow up at runtime. Right? You won't get the errors. But you might end up with logic errors. You might end up with something not working the way you expect it to, or something like that. So,
Just the fact that it's not crashing, it's even a bit better, you know.
Especially on the
It's
local
better to
side.
have a bug than getting the crash, right? So.
Yeah, I wanted to kind of learn more about more specific examples of where the benefits are. So for example, I think lazy evaluation using stream. I think converting traditional loop into stream and lazy evaluation for certain cases, they can actually have pretty good performance improvement and potentially better memory utilization because we don't have to evaluate everything. So do you have any more specific examples where we can see a lot of benefit utilizing this versus where it doesn't have much more benefit than traditional way?
I'd say I think it's much easier to get to that lower footprint lazy evaluation way using streams. I think in many of your traditional loops, you'll see people making effort to accomplish that lazy evaluation that you kind of get, I don't want to say for free, but is kind of built into the DNA of the streams. So it's much easier and concise to express that. I think in the end, you can make loops that are probably as efficient as a stream. But I think streams make it a whole lot easier to do it on your side. For the performance side, I don't have specific examples. I don't know if you do.
You know what, I don't have it here, but there's a book by Venkat. Yeah, which is called Functional Programming in Java. and he goes in depth on it. So I would point you to that because we might have used it in the code, but we don't have anything here to show you. But
That's a good one. I've read some of that.
yeah.
It's lower memory footprint. Also, you're seeing computer machines coming out with more processors, and so this is kind of oriented towards parallel
Right.
processing and leverage. So if you're not going to get more speed out of your machine, you're going to dump more processors, and I've heard that a lot of this Java 8 stuff is really oriented towards that. So you could, writing a
It
program
can-
in style is going to leverage all that and run it all, so you'll get a performance gain.
Right, as long as you don't run into the threading sort of issues that you were
Right. Well,
describing.
I bet they fix it. I mean,
On the other hand, did you guys run into any issues?
Yeah, I can.
Migrating to Java?
Yeah, so the one issue I remember was that Javadoc lint was complaining on mainland. That was one issue we had to turn it off. That was the one issue I remember that we ran into. And that's, besides that, we didn't. No, it was fine.
I think you mentioned some potentially memory leakage issue where, after 2 days of running.
Oh, no, that's, okay, so what I was mentioning, okay, so that's, I'm talking about G1 garbage collector.
Okay.
And we were, there's the Winding study group, and we were going through garbage collection algorithms. And the guy, Doug, the guy who runs it, he tried G1 collector because that's gonna be great. He had a big server, like a server with a big memory footprint and lots of processors. And he had 2 servers, and they had little different performance characteristics. Like I can't remember details, but he set up the same G1 GC on both of them, configured on both of them, and one of them was doing great. He said he specified, like, he really tuned it. Like, he specified he wanted to tune how long the GC pause it's gonna take, and how many threads to use it, and one server was behaving great. He said he got a good benefit from it, but the second one would run out of memory after a couple of days. And basically what we kind of evaluated, what we were suspecting that the pause that he specified, he limited the pause for GC, and his pause was too short, so the GC collection came in, but it said, okay, you have to limit it to just that much time, and it would just increase, right? So, and at some point it would fail. So that was our suspicion. But like with every GC garbage collection algorithm, you gotta tune it, you gotta test it, right? So.
Yep, thank you.
Cool, any other questions, any other comments?
I was wondering if you guys have had any problems with the more stricter code validation. Have you seen problems with that?
No.
One time I tried to upgrade an app to run in Java 8. I think it was due to the fact that I had older libraries, especially with Makito and bytecode generation, and the bytecode validator would just reject a lot of crap.
Sorry, look at this blog, because I think that's what, I think, if I remember reading it correctly, the
Early ASM had problems with it, I know.
ASM, yes, that's what they mentioned, yeah.
So if you have an old ASM sitting on your class method, yes,
I suppose since this thing was built on Spring 3, it probably just simply won't even work without upgrading, you know what I mean? But
You know what, I
I was
remember,
wondering if this is a common problem or not.
yes, I had one more problem with Java 8. I had to upgrade Gatling from 1.5 to 2.03.
Oh,
If you think what Gatling is.
I like a performance tools grid.
Scala.
Did you have a question or?
Yeah,
comment?
I'm currently migrating to Java 8 in my project, and face the same problem you mentioned. Since I'm pretty new to Java 8, I don't know much about this style, what's recommended way. And one of the problem was when I try to apply those lambda expression with existing style with, so in old style, I've been using Java function interfaces.
Yeah.
And a little bit more implemented in my way, but Java 8 doesn't allow me to throw exception, as you said, so I just implemented my own interface and just add functional interface annotation on that.
Right.
I wonder if that's the right direction to do that?
Well,
What about that?
That's what, yes, that's kind of what we did, but we kind of did more structured way. We basically eat the exception. We collect everything, run through everything, right? And we collect the results. And then we inspect the results, get all the errors and get all the successes, right? So I think this is the right approach to do that. Well, one thing you could do if you really want to throw an exception, just convert it to runtime, right? And you can just do it inline, and you're fine, right? And the second, if you want to do something totally cool, use this library, the Weber expression library. But does it answer your question? If you throw a checked exception, you can inline with the lambda just catch it and convert it to runtime exception. And then the code is gonna behave the same way as it was before.
And I've also noticed that Spring, before Spring 4.0.3, Java 8 is not officially supported.
Okay.
So, do you think there's any problem using old
I-
version of Spring?
I
project?
don't know. I think we use 4.0 to 4.1. I can't answer that. I'm not sure because we're using newer version, so I didn't research the older version.
How about Tomcat? Do you have any?
Tomcat? Yeah, we're using Tomcat 7.
Do you know if there's any problem?
No, we
Tomcat
don't.
6 or 7?
I think it should always be backwards.
It's all,
Which would
yeah.
just work. If you have
It's your
tests,
word, right?
yeah, well,
It's,
if you have tests, great, so
so
they validate.
okay, so we like I said, we have a very extensive functional test suite. We also did a lot of performance testing because we were getting ready for ESPN, so we get a lot of big loads, and we didn't run into any issues with Tomcat 7 and Java 8. And we're running on the early version of Java 8, Java 8.05, because apparently it's very hard to get the upgrade version.
All right,
So, yeah.
thanks.
Cool. All right.